Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be talking about compound interest. So it's a way of kind of exponential growth that uses a little bit of a different formula. So let's go ahead and let's start by taking a look at that formula. So taking a look at this is the compound interest formula. A is going to represent your ending amount. So that's really what you're trying to calculate. P is going to represent your starting amount or your principal. R is your interest rate. Now, 90% of the time is going to be given to you as a percent, so you want to make sure you convert that into a decimal. And then N is the number of times that it is compounded per year, and T is going to represent the number of years. So we do kind of want to look at this chart and make sure we understand what each of these values of N kind of mean. So for something to be calculated annually, that means it's only going to be counted once a year. So annually is when N is equal to 1. Semi-annually is going to be twice a year. Quarterly is 4 times a year. If you think about quarter, there's 4 quarters in a dollar. Monthly, there's 12 months in the year, so that's going to be 12. Weekly, there's 52 in a year. And daily is 365. We're going to pretend there's no leap year. Okay, so that is each of those N values. So it's nice to have those charts so that as you're calculating through those, you make sure you have those N values available to you. So let's go ahead and let's take a look at number 1. It says Maria's parents invested $14,000. So that's going to be my P, not my A. That's going to be my P. Okay? Then at 6% per year, well, 6% as a decimal is 0.06. Okay, compounded monthly. So that means N is going to be equal to 12. So when you're looking for what your N is going to represent, you want to look for words that end in LY. That typically is what's going to give you what your N is, and then you can go back to your chart. And so we're going to be calculating it after 10 years. So that's going to be our T. So let's go ahead and let's plug that in. So I have 14,000 times 1 plus 0.06 divided by the number of times per year, which is 12, raised to the number of times per year times the number of years. Okay? So first thing I want to do is multiply out that exponent. So I'm actually going to keep this as the same thing in the parentheses. Some students like to go through and actually divide this out, but I will tell you the earlier you round, the less accurate your answer is going to be. I do like to take the extra step, though, to multiply out the exponents. So 12 times 10 is 120. So I get that, okay? So now we can go ahead and plug this into our calculator. We can type it in exactly like this. The biggest thing is that you make sure you put those parentheses in there. So why don't you go ahead, pause the video, and try punching this in yourself. When I punched it, I got 25,471.55. So when we talk about money, we usually have 2 decimal points after. Okay, so since we have 2 decimal points after, we always want to look at that third number to figure out how we're going to round. So you need to be really careful of your rounding because I do take points off if you round incorrectly. Okay, so let's go ahead and let's take a look at number 2. So for number 2, the amount invested is 300. Well, that's going to be my P, or my starting value. Okay, and a rate of 3.5. So that's going to be 0.035 when I can convert it to a decimal. Compounded semi-annually, well, that's going to be twice a year for 22 years. So I'm going to do 2 times 22 up top. So I do want to take the extra step. Wow, that's super annoying. So 2 times 22. So that's going to be divided by 2, and then 2 times 22. So I do want to actually multiply out 2 times 22. So I personally like to leave all of this the same because, again, rounding early will affect your answer. 2 times 22 is 44. So this right here is what I type into my calculator. 300 times 1 plus 0.035 divided by 2 raised to the 44th power. So when we do that, we end up getting 643.63. So $643.63. Okay, so that's our final answer for number 2. Again, it's always good to be calculating it along with me, so you can also check your rounding. Remember, if that third number is 5 or greater, you round up. If it's 4 or below, you round down. All right, so let's take a look at this one. Your allowance goes $190 with 11% compounded monthly, so that means that my N is going to be 12. Okay, so we're starting with $190. So we have $190. And we're going to do a rate of 11%, which is 0.11, because remember you're moving that decimal point left 2 places. Divided by the number of times per year, which is going to be 12, because we're talking about monthly. Raised to the number of times per year times the number of years, which is 1.5. So remember the extra step that I take is to, wow, that got to be a hot mess. Okay, 12. Seriously, I keep accidentally hitting the eraser with my palm, which is why it keeps erasing it when I'm trying to write it. Okay, so we're going to take and multiply 12 times 1.5. So then I get 190 times 1 plus 0.11 to the 12th. Then 12 times 1.5, well, that's going to give us 18. So then I can go ahead and plug this entire thing into my calculator. Again, those parentheses are really important. And when I do that, I get 223.92. So if for some reason you're not getting the same answers as me, definitely let me know so I can take a look at what you're getting in your calculator and what you're typing in. And again, please make sure you're watching your rounding. So let's go ahead and let's take a look at this one. So we're starting off and we get $440. Okay, 5.8%. So I'm going to go ahead and plug that in, and that's going to be 0.058 compounded annually, which means it's only going to be compounded 1 time per year. So then what we're going to do is we are going to do 8 times 1. So I'm just going to rewrite this out for a second. So I have 440 times 1 plus 0.058 to the 8th power. So something I want you guys to notice about this is if it's compounded annually, it actually is just the growth formula. Okay, so here's your C, your start value, here's your rate, and here's your number of years. So really, they're the same thing, these growth and the compound interest formula, but we need the compound interest formula if we're doing something more than once per year. Okay, so I just kind of wanted to point that out to you, but in general, you could still have very well used that and just done it the same way. I just wanted to point out to you that when it's annually, it's the same as growth. So then when I type that into my calculator, I end up getting $690.78. So something I want to take a second to talk about is like, why are we figuring all of this money out? When is this useful? Well, something this is useful for is when you put money in the bank, you gain interest on your money that you have in the bank, because the bank is basically borrowing your money. Okay, and when you set your interest rate, it'll say, okay, this interest is going to be compounded monthly, weekly. Okay, and this formula right here is what the bank uses to figure out how much you're going to pay. So the reason that this is so helpful is you can actually compare different banks and say, okay, if I'm investing for 5 years, does the higher rate compounded less often or the lower rate compounded more often help me out? And you can actually calculate it out. So that's what this is actually doing, just as a fun side fact. Okay, so let's go ahead and take a look at this one. So we're starting off with $54,000 in the bank. I wish I had $54,000 in my bank. Okay, so this is a car loan. So what we're actually trying to figure out is, okay, this car costs $54,000, but I'm taking out a loan at 15.1%. How much am I actually going to have to pay after 2 years? So this is actually super relevant. So since it's 15.1, that's going to convert to 0.151 as a decimal. Now it's going to be compounded daily. Okay, so we need to divide it by 365, and then we're going to raise it to the 365 times 2, because we're talking about it for 2 years. So I'm going to go ahead and multiply that out. So I have 54,000 times 1 plus 0.151, oops, 0.151 divided by 365, and that's going to be raised to the 730 power, because that's what I get when I multiply those two together. So when you go and multiply this out, you end up getting $73,304.24. So this is why loans are a big deal. So the car itself only costs $54,200. But when you have to take out a loan, when you borrow money, they charge interest on that loan. So if it takes you 2 years to pay off that car, this is how much money you're going to pay in total, even though the car was only worth $54,000, because you're collecting interest on that loan. So that's just something to think about when you think about student loans and getting college scholarship. The less you have to take out as a loan, the less that interest rate is going to be for you. Last but not least, let's take a look at the 16-year investment, okay, at $40,000 at 14% is compounded weekly. So we're starting off with $40,000. Okay, so then we have a rate of 0.14%. Okay, compounded weekly, and there's 52 weeks in a year. So that's what I'm going to put down there is 52. Okay, then that's going to be raised to the 52 times the number of years, which is 16. So now I want to actually take and multiply out 52 times 16. So I get 40,000 times 1 plus 0.14 divided by 52 raised to the 52 times 16, which is 832. So now I can go ahead and plug this into my calculator. So again, when I do that, I want you doing it along with me so you can check your answer. So when I did that, I ended up getting, oops, I only did 4,000 when I calculated it. I have to recalculate it. So 40,000 times 1 plus 0.14 divided by 52 raised to the 832 power. So when I do that, here's what I get. So this is a lot of money that got raised. So this is one of those reasons for putting money in the bank early so you can be collecting interest on it. But I guarantee you, you will not find a bank that pays you 14% interest. So you would end up getting $374,604. Okay, so that concludes your note video for today. Thanks for listening.